In this particular set of notes, we're going to talk about systems of linear equations. So in general, the term systems of equations means that we're actually going to have two functions at the same time, if you will. Now, we're going to see through the next couple lessons that there are multiple ways to solve systems of equations. We're going to start with the first method of solving systems of equations, and that's through graphing. Now, we're going to keep our lessons limited to linear equations, so we're going to be dealing with linear functions. Now, keep in mind that since we have two linear functions on a graph at the same time, the whole thing by itself is not a function. We're talking about two separate functions being used together, and we're going to see what that creates and how we find answers for that. And so you can basically see here we have a first example with equation 1 and equation 2, and both of these equations are written in standard form. Your system of equations could also be written in slope-intercept form, so long as there's two and you have an x and a y in both of them, or if you don't have an x and y in both of them, you're probably dealing with vertical or a horizontal line, so just keeping those special circumstances in your mind. So what we're trying to do when we're looking at solving a system of linear equations is to find the solution. Solution is just a special word for what is the answer. And in this case, remember, a solution is an ordered pair that makes the linear equation a true statement. And so that's basically what we're doing here, is trying to find an ordered pair that makes the linear equation a true statement. Now, the fact that we're dealing with two linear equations, the same ordered pair has to make both linear equations a true statement. And so basically what that looks like graphically is an intersection. So if we were to draw two lines and they were to cross, the point where they intersect would actually be the ordered pair that would create a true statement for both of them. So it's important that you understand what a solution is and what it looks like. There will be a few special circumstances in this particular set of notes that you need to be familiar with. So let's just take a quick example here and see if we can just identify a solution. And so example 1 says to check these two ordered pairs to see if they're solutions to the system of equations. And so the way we do that is simply to evaluate by plugging in the ordered pair into the equations, and if it creates two true statements, then we know it is a solution to the system. And so you can see for part A, we plug in the ordered pair 2, 2 to both equations, and we get a true statement in both cases. And so since that's the case, 2, 2 would be a solution or the point of intersection. Keep in mind, in this case, 2, 2 would be a point of intersection if we're looking at a graph. Now, it should seem fairly obvious to you at this point that there can be only one point of intersection between two lines. So if 2, 2 is a solution to the system of equations, and it is the point of intersection, then 0, negative 1 could not be. But you could still test it. And so if we look at part B, we took 0, negative 1 and we plugged it in, and you can see that it fits for one of them, which means that 0, negative 1 is a true statement for equation 1, which means that it is a point on that particular line. It is just not a point on both lines because it doesn't check for the second equation. And so just because it works for one doesn't mean it's a solution to the system. So let's keep that in mind as well. So go ahead and take the time right now to pause the video. Sample problem number 1, we're just simply asking you to check if those are solutions to the systems of equations. So go ahead and do that at this point. Okay, so I'm going to start with part A. I'm going to check these equations for the ordered pair 1, 4. So I'm going to plug in 1 for x minus 3 times 4 equals negative 5. It's going to give me 1 minus 12. And that's going to give me negative 11, which clearly does not equal to negative 5. And so in this particular case, since that statement is false, that's a false statement, it's not a solution. Now notice I didn't even have to check the second equation, because if it's not a solution for one of the lines, it can't be a solution for both of the lines. So that's a good indication we can go ahead and stop. Alright, for part B, negative 5, 0, we'll go ahead and plug that into both parts. So that's negative 5 minus 3 times 0 equals negative 5. And of course that gives us negative 5 equals negative 5. So we're good so far. That's true, but just because it's true for one doesn't mean it's true for both. So we must test both of them. So we're going to take the second equation and plug in our values. And then that's going to give us 10 equals to 10, which is also true. And so we can say that this is a solution. And since it's a solution, that is the point where the two graphs would intersect. Okay, and that's just a quick introduction to systems of equations. In the remaining videos, we'll look at how we solve these by using graphing.